Okay, good afternoon, everyone. Welcome to our webinar, where we're going to focus on the benefits of creating digital twins and virtual commissioning for end users. So this is very much an introductory session. We hope to plan further webinars later in the year that focus on several industry-specific areas, so please look out for those. Just to introduce us, my name is Graham Carter. I'm the founder and managing director of Autologic Systems, and also with me today is Andy Parsons, our sales and business development director.
Hi guys, thanks for the introduction, Graham.
So we're on a bit of a tight schedule, about 30 minutes, so let's get stuck into it. I'll give you a quick overview of what we're going to show and talk about. So I'll start off and give a quick overview of the company, and then I'll hand over to Andy, who's going to talk about digital twins, what they mean to Autologic, and where we use them. He'll also give some digital twin examples of how end users can benefit from them and some use cases. And then we'll take you, I think we've got 3 examples, case studies to take you through, that Andy will go through with you. And we'll look at how some of our customers are using digital twins and how they're benefiting from them. Questions are welcome at any time. We'll deal with them at the end. We need to get done in about 30 minutes, so we'll try our best to be finished on time, and we'll try to deal with any questions at the end. Please ask them through the Q&A facility. There's no chat available, I don't think. Okay, great. So just to kick off, a bit of background to Autologic Systems. We celebrated our 30-year anniversary last year in November, so established in 1993. Established very much doing the same things that we do today. So we were always providing 3D digital twins to customers with typically of simulation models and providing a consulting service. In 2005, we partnered with a company called Emulate3D, and they were developing some highly innovative software at the time for digital twins. So we signed a distribution agreement with Emulate3D around 2005. That software, like I say, was highly innovative and was picked up by Rockwell Automation, who've been using it for a while. And in 2019, Rockwell acquired the Emulate3D company and the product of the same name. And then in 2022, Rutico, who are the main UK and European distributor for Rockwell Automation, they acquired Autologic Systems. So in terms of Autologic Systems today, we're now majority owned by the Rutico Group. They're a £300 million company, and we're part of the Sonepar group of companies, which are, they operate in about 40 countries, about 32 billion euro turnover. So we're part of an extremely large group today. The software that we provide, the products that we sell, include the Emulate3D software for digital twin applications, and we'll see a lot more of that software today. We also provide the TOPS software, which is for case, pallet and vehicle optimization. We have a large number of customers in that area as well, beyond the scope of what we can talk about today. So if you want to know a little more about that software, then please feel free to get in touch. And then to support the sales of the products and the software we provide, we have a consulting service where we help our customers to build digital twins. We also have a training service, and that's very much not just standard training, but we're helping customers that are using our software, and we're helping them in a hand-holding consulting way, or we're mentoring them so they can build their own models. And then finally, we have technical support. So this is providing our customers with the help that they need when they're using our software. So they can ask the how do I type questions, and we can provide them with the guidance that they need when they're using the software. Okay, so I'm going to hand over to Andy now, who's going to introduce digital twins in a bit more detail and the benefits, and explain. I think he's going to start by explaining a little bit more about what digital twins mean in Autologic's world. Is that right, Andy?
That's it. Thanks, Graham.
Okay.
Okay, so digital twins, they typically fall into, in simple terms, a couple of categories. Those that are based on the physical world and those that are more data-driven. Your data-driven digital twins, typically driven by historical data that drive our plants, or recorded data from our operational from our operations through intelligent sensors and intelligent drives, that kind of thing. The world of Autologic is more focused around the physical-based digital twin, which is what we're going to look at today. So when we talk about the physical digital twin, imagine your machines, your robotics, your wider transportation systems, your entire production lines, logistics facilities, your process lines and your process equipment. Imagine all that plant being available in the virtual world, in software, and we can bring it to life and we can put product through it. Okay, so we have this virtual dynamically running plant, and we can leverage that pretty much however we want to. We're often driven by inputs into these digital twins come from the CAD world, 2D and 3D CAD, the physics world. We can be interested in the weight of our product and resultant coefficient of frictions and things like that. So sometimes we get a little bit more abstract, where we don't include all the mechanical detail, and we have what we call black box models. Okay, so digital twins, there's a workflow associated with them and how we can use them, from just demonstrating ideas and concepts, being able to bring them to life in a very visual way. We can validate, not just demonstrate, but validate those designs and those ideas through simulation. The world of virtual commissioning is open to us. And if we've done our virtual commissioning, we very much have access to operator training environments. And this is very much for new and existing plants. We've got a little video that we'd like to show now that just brings it to life a little bit. So this is in this case it's a non-proprietary video, which we can share this with you. But this is the kind of thing we mean by the physical world. We can see our product moving around. Our axes on our automation have come to life. Everything's accurate in terms geometrically, in terms of the geometry is accurate, but the timings, time and space. So we're respecting acceleration, deceleration, target velocities of our drives. So you can see from this sort of standard of output, it's a very visual, it's a very engaging piece. And, for all the stakeholders in a scenario to understand the concept of what is being presented. There's very little out of scope when it comes to what you can do in the physical world, whether it's vehicles and the AMRs that you can see here, the robotics, the transportation, all the machine. We can bring different types of machinery to life, and you'll see shortly the process world. That's been something Autologic we've got involved in a lot of, since about 2015, 2016 on some project work, and now there's a lot more activity in our world with process capability. Okay, so imagine what we could do with this plant if we could. Well, yes, you can see we can visualize it, but you know, we can leverage this to the extent where we can test it and we can prove it. And the software that's going to control this plant on site, whether it's at a lower level PLC automation control level or a higher level information layer material flow such as an MES, or your warehouse control software, that connects into Emulate 3D, thinking that we're the real world. Okay.
Right. Move on.
So just to expand a little bit on this workflow that we talk about, if we go from left to right on the screen, the demonstration capability, I think you've already seen that, but bringing early ideas to life and concepts, very much reusing you know, engineering statements, 2D and 3D mechanically designed CAD, architectural statements, you know, which identify our building constraints. All this type of data can very much frame a lot of what we're trying to achieve with our digital twins in the physical space. It gives us very early engagement with our stakeholders, and that early engagement is a great way of building trust. You know, it's a collaborative space for end users, but also the supply base, the equipment manufacturers, and the guys and the integrators who integrate the equipment. It's a great collaborative space to ensure that you know, we can get our designs right from the ground up. An excellent design review space. We do quite a bit of virtual reality work here as well, which is a very I know it's not for everybody, the virtual reality headsets, but they do give you a very personal view on a particular design and particular features within a design. You know, that help we understand if things are too high, too small, if they're too constrained. It promotes more questioning around how the process is going to achieve its success. So our ideas and concepts mature into scheme designs and final designs, which brings us into the simulation space. So here, this is the robust space of proving a throughput. Okay, we want to understand the capacity of our plant. What's its limits at peak? You know, what is it? Can we identify any bottlenecks? And if we do, this is a space where we can identify the bottlenecks and remove them as a project team. So this is all about, before you sign a design off, before any money gets spent at you know, materials, parts, etc. Before that all gets signed off for spend, we're reducing that investment risk. We flow from we've done our design sign off, and we move into the opportunity is there to move into the world of virtual commissioning. So we're taking our commissioning of our automated plant off the critical path. Okay, we connect to we communicate into our PLC and our higher level software layers, and that allows us, you know, those environments think that the digital twin is the real world. Okay, and we can prove out our PLC logic and our material flow layer logic that's going to control the site. And they can be, you know, they're tricky scenarios to solve sometimes, and they carry the risk, often carry the risk of overruns. And there's, you know, sometimes significant cost in that space. So we are de-risking, but the opportunity is very much to save time as well. And we'll drill into that a little bit more. Having done our virtual commissioning, you know, that environment, you've essentially developed yourself an operator training space. Okay, so think of your as an almost like an architecture diagram. There's your PLC, your HMI screens that the operator interfaces with, and it's not the physical plant, it's the virtual plant, but you know, you're very much testing and interacting with instances of the software that are going to go to site. And that means we don't need possession of the plant to run our training scenarios and our fault. We can put our virtual plant into fault, and we can ask the trainees to recover those faults. It's an excellent space for that. So we've focused on some headline spaces, applications and benefits, particularly for end users. So think of existing plants before there's any changes. We can, your engineers on site will see, they will have identified themselves where there's bottlenecks, there's blockages, or there's starvation, or processes that are linked together that they can see could be performing, could be more efficient. Okay, take those scenarios into your digital world, and it's a risk-free environment where we can test ideas. But before we make any changes to the physical plants, we can test all of the software that's going to go into the production PLC and into our MES layer or warehouse control layer. We can prove all those changes out before we go live. We often get involved in we talked about this black box modeling where we don't have the mechanical detail. You just play that video, Graham. This is a little hybrid video where on the top left-hand side is the mechanical model, but prior to the mechanical model came the black box model, as we call it. So our individual processes are modeled. They all connect together. Each process has its capacity and it has its constraints. A process will need some in-feed before that process can start. Those in-feeds might be really specific. Then there's a process time. Then they need to out-feed to the next process. And if there's not capacity there, then I'm blocked, or I might be starved of in-feed. And all of that analysis, there's some fairly strong data statements that drive these models, but it's all about identifying, getting a grip on your existing plant and understanding how you can improve the OEE, as people talked about, the overall equipment effectiveness, which is a topic in itself, but it's really about how can I improve the truly productive time in my plant. Thanks, Graham. De-risking hardware upgrades. Older plant, 20, 25, 30-year-old plant running on older hardware platforms. There's often there's often nervousness about going through those upgrades, and often they don't happen for that reason. It's the desire to keep the plant running, any nervousness around not having the plant available after the upgrade. It's always a short shutdown window. Okay, so let's take those PLC zones that are the hardware's being upgraded. There's new drives, there's the modern, the latest PLC platforms, and do our virtual commissioning space. That's a piece we can do and ensure, if you do that, your shutdown windows, you're going to guarantee, you're guaranteeing that the plant is going to be available on the Monday morning after the weekend shutdown. There's software around that does supports those hardware upgrades. There are tools to support that space. But the digital twin is a belts and braces approach. So if the stakeholders identify a risk to the business, if the cost per hour of lost production, if the plant's not up and running, if there's a threat there, if there's a risk there, then there's a belts and braces approach with the digital twin. Supports us there. And if we've done a digital twin for our upgrade, very likely, there's going to be a chance to that software was 30 years old and it's been migrated, and there'll be opportunities to continue to optimize that plant and opportunities for throughput. We can do that in a very safe space, and we can keep testing because we're away from that. We don't need possession of the plant to do that continued optimization. There's some challenges around, you've got to understand the PLC. No one's very unlikely someone will know that software from 25, 30 years ago. The older plant, it might not be documented so well, and we often find ourselves, we'll just go on site with our laser measure and a tachometer and start measuring time and distance to feed into the digital twin. The new plant and upgrades to plant, where there's new designs, it just fits the workflow that digital twins can offer you. From the if it's a completely new space, there'll be some new architectural statement, and that's our starting point inside the digital twin, and we can just plan in our 3D world, just even in statically laying out our new plant and seeing how it looks and fits visually. And then we get into our design reviews and we hone that design before we get to the right. Let's validate this design from a throughput and production schedule, or and the orders going out of our logistics facility, or the tonnage that we need to process into our production tanks. We can that whole workflow that digital twin just it lends itself to new designs. Okay. Third headline, we've discussed virtual commissioning, but it's about just the key bullet points there are about de-risking to avoid costly overruns. But it's not just about the de-risk, it's about getting back to market or getting to market faster. Okay, we have access to virtual product. Okay, we can hit the reset button in our digital twin, and then we can load product up on at the press of a button. It's stuff you can't do on site, and that that automatically speeds up our testing process. So we're about reducing costs, de-risking overruns. There'll be reduced waste, there'll be less mistakes, and you naturally do more robust testing. It supports remote working. Point to make on we don't need the physical PLC, we can work with the virtual PLC. So we don't need the hardware in the loop for our virtual commissioning. And that digital twin, that virtual commissioning, is available for future use. Virtual training environments we've talked about. If we just quickly show what that can look like. This is a nice little video from our friends at Emulate 3D. They've done a great job here showing off the virtual training aspects. So we're in the virtual headset, we can see the HMI, we can interact with the HMI, and that allows us to, and we're interacting with the plant. In this case, we're loading up product according to instructions from the HMI, and we've added a few nice training facilities features as well, to the big green arrows, giving you a bit of help in that space as well. Okay. Just to quickly quantify what we've talked about, it's about those OEE percentage gains. What that means is that's private to the end user in terms of your unit costs of handling and production and your selling prices, but you get percentage gains with these techniques, and you'll know what that means to you financially. We've seen some massive reductions in commissioning times. We can take up to sort of 50%. It's typically in our experience with our work, it's sort of 25 to 35%. We've seen up to 50%. And one of the case studies we're going to show you is beyond that as well. The operator training space is growing rapidly in terms of it's just the virtual plant you're training on rather than the physical plant has significant benefits. There's all our end users we talk to express pain around the continued training need, and the possession of the plant is difficult. De-risking costly design errors, de-risking costly commissioning overruns, and it's an opportunity to do more testing and be more optimal and be more efficient. And it's a fantastic collaboration space with the end user and the supply base. The best work we see, the best projects we're involved with, is when there's a collaborative space where the end user is supporting the digital twin work, and encouraging the digital twin work, and encouraging the OEMs and the SIs to be part of that. And it's been fantastic.
Great, thanks, Andy. Let's take a look at some some case studies.
Yep. Okay. First one. So this is a bottling line. It's so mostly a new. Most components of the line are new. There's a legacy palletizer that wasn't new. That was on a legacy palletizer, different hardware platform. But it's very much in simulation, a line balancing study. Okay, and testing format variations and how to balance the line and to control the buffers between our processes, and then having established that line balancing strategy, that we virtually commissioned the transport layer when that strategy was built into the new PLC transport layer. And we did so. We sized up mechanically sized up a buffer in front of the legacy palletizer. Okay, I'm going to quickly show that video, Graham.
Yeah, let's take a quick look at this one.
You see the 2D CAD statements, familiar to most of us, I'm sure. And we can put our product through. We've got from bottle singulation downstream. There's different formats we'll run through this. This is showing it not in the physics world in this particular case, but if we have the physics world engaged, then the center of gravity of our bottles and the weight and the resultant coefficient of frictions all come into play. But between our processes, the conveyor, it's all conveyor between processes, and that acts as the buffer. And how we control the variable speed of those drives and the position of our sensors are all there to gain and improve our OEE, the truly productive time, avoiding, what do we do when we're blocked, the best way to handle it, how do we keep the upstream running, how do we avoid starvation from between our, there's 5 or 6 connected processes here. If you just slide that forward, Graham, we'll get to
sure.
Just show a bit of.
We've had a question, Andy.
Okay, what have we got here?
We've got our engineers create our CAD models. Can they create the digital twins in-house too? And how easy or difficult is that to upskill?
Yeah. So the software, the software solution that we use is Emulate 3D, which is commercially available software. Autologic can support in that space with training as well. So yes, it is software that can sit inside the end user. We provide a service when companies don't want to do that, or they're too busy. So there is the whole workflow that the software offers. It's a single skill set. Okay, yeah. So if you get that skill set, then you can work in the design space and in the virtual commissioning space and prepare your operator training space as well.
And those CAD engineers can work in a kind of a bi-directional environment now, I understand, where they can be taking CAD models from that into Emulate 3D, but then taking the changes back into their CAD.
Yeah, absolutely. We take these CAD models and we make them dynamic, and a lot of those feature sets to bring that CAD to life, they can sit natively in the CAD package. So the mechanical engineers can work in their native environments and export them. And we have a backwards and forwards with the digital twin and the CAD software.
Great. Okay, we've started to run out of time.
We are, absolutely. It's entirely my fault.
No, that's fine. Let's get on to the
this one's
next one.
Yeah.
Sorry, I'm going the wrong way. Okay, there we go.
Okay, this is for we can release this into we have media release on this. This is for GA Pet Foods, a large pet food manufacturer. They struggled in the past with their MES layer, so the material flow layer into their automated plant. And previous project they classed as a failure because they never got the MES layer where they wanted it. They were just, in the end, they were just happy to get their plant running. And then, once the plant was running, they never went back to their MES logic to optimize it. So this is how we got together. GA Pet Foods did this themselves. We're really chuffed with this. We gave them some training, a little bit of support doing their project, but this is all their work, and it was great. Some of the benefits, the significant benefits, customers have stated themselves, they're shortened by 3 to 4 months than what they planned. And we've got to the point where, as of December, we were with them. They finished their physical commissioning, and they've done all their virtual sign off, and the physical commissioning went first time. So it's a massive success story, which they're happy to talk about it, which is great.
And they got the reduction from 14 to 2 days for machine commissioning, which was pretty
Yeah,
spectacular.
yeah, and it was all done, and that was during the pandemic, wasn't it? They had to,
all
they were
done
forced
remotely in the
into it.
pandemic.
They're forced to do it remotely, and it all 14 down to 2 days, quite incredible. This plant covered a lot of distance. The meterage from transporting the pet food around the process, storing it, and then dosing it, and then out the door, some real big distances. And that it was just we overcame that in the digital world, and it was a fantastic tick in the box for these guys.
So our final case study, Andy.
Yeah, this is for Nestle. We're a confectionery world. This is a big distribution facility. It was Nestle's first automated distribution facility, and they de-risked it through digital twinning. Do you want to play that video, Graham? And then we'll talk through.
We pretty much did all the work on this one, Andy. Is that right?
Yeah. No, this is all
our consulting work. This one.
Good collaboration with the end user. There's a third-party haulier who are running this site. The OEM, Swisslog, were doing the build, and Autologic, we sat in that digital twin space. And it was a great collaboration. But
they were so delighted, Andy. If I remember, they were so delighted they dropped a mixed pallet load of confectionery off to our offices at the end of it.
That pleased us all. That pleased us all. Mind you, I don't think I got too close to it because the team got to it first. The team got to it first, but this is the the ability to just have this in the digital world, right? To be able to de-risk this, £50 million worth of automation build. Whether it's £1 million or £500,000 of integration, it doesn't matter, does it? It's about, as long as if the cost of doing the digital twin and the effort is rightly proportionate to the overall investment, then you have to say what's not to like. If you've got a 3-month commissioning window and it takes you 6 months to build your digital twin, we're probably failing in our digital world. So it's about the ability to build quickly, to solve our challenges.
Okay, so we're a little bit over time, but I think we're just about time to go through the last couple of slides, Andy. Yep.
Just a final slide, just to mention Emulate 3D, why it's our tool of choice. We go back a long way with the software, and Rockwell own it now, and they're investing in it. It's where it's fantastic to see the development team grow and the support team grow. But it's a single platform for all application areas. So if you can, you get one skill set, and you take control over this whole workflow that we've talked about. Integrates with all the major CAD systems, the bi-directional piece that Graham mentioned. The mechanical designers can stay to a large degree in their native space and then pump out information into the digital twin world. We're agnostic of PLC hardware. We communicate natively with all the main PLC manufacturers, which is a massive strength in the market. So that works really well for us. The VR world has been nothing but great for us in the design reviews, and to see end users embrace it. Once they've started in this world, they never let it go. So that's been great. And the reusable catalog capability, to be able to build quickly. If you've got catalogs of what you need in your plant, your speed of build goes through the roof, and you're definitely winning.
Sometimes, in that space. Andy, we'll build custom catalogs for our customers. Is that right? So we'll do we'll create a specific industry-specific catalog for customers, and then they can plug those bits together and dimension them themselves. Yep.
Yeah, absolutely. Which takes away, there's some of that, we often sit in that space where, the more challenging piece, we can take on that and then send that back to a customer.
Okay, so just to close up.
Yeah. That was 100 miles an hour. But hopefully, you saw a lot of features there that you would like to see. We've seen it. We've got, as Autologic, we've probably got pushing upwards of 700 case studies with the software and the digital twinning over a lot of years. but we've seen how end users benefit and how once they see it, they want to keep doing it. From that perspective, there's benefits from the early ideas and concepts through into the commissioning, the operator training space, and existing plant can be improved. So it's the project life cycle is very much in scope, and the gains in the gains in OEE and commissioning, reduction in commissioning times and operator training, getting operators up to that level of experience where they can be released onto the plant it's absolutely the way forward. We're obviously passionate about it, but it's we've seen it deliver.
Brilliant. Okay, thanks, Andy. I'm just checking on questions. I don't think there are any others. So we'll leave it there unless there's any last minute questions. Great. Okay. Well, thanks for joining, everyone. And like I say, watch this space in case we do some more industry specific webinars later this year. But thanks once again.
Thanks all for your time. Thank you.